In this video, I'll show you how to find the domain and range of functions. This is part 3 in the series. The first question reads, find the domain and range of y is equal to the square root of x squared minus 25. Remember, when determining the domain, we want to find all of the values of x for which the function is not defined. Now, since our equation contains a square root, we know that this part, known as the radicand, must be greater or equal to 0 for you to produce an output y. So x squared minus 25 must be greater or equal to 0. Normally what we would do from here is we would solve for x. But you'll notice that we have x squared. Look what happens if we solve for x squared. If I bring this negative 25 over, it becomes positive 25, x squared. And if I square root both sides, I end up with x must be greater or equal to the square root of 25, which results to plus minus 5. Now, here's the problem with this. If I put this on a number line, let's say that this is 0, and x, when it's greater than 5, would look like this. So anything greater or equal to 5 would look like this. And x must be greater or equal to negative 5. X being greater than negative 5 means everything going this way. So there's a contradiction of some sort. What you need to do when you have a quadratic inside of a radical is you have to look at it from a logical standpoint. Remember, this quadratic, x squared minus 25, would look like this on a graph. You would have two roots, one at 5 and one at negative 5, and it would open upwards because x squared is positive. So you would have something that looks like this, where you have a vertex at negative 25. It would pass through positive 5, and it would pass through negative 5. Now we have to find x values for when y, this part, is greater than 0 or equal to 0. And the only time that happens is from here onwards and from here onwards to the right. So you have to be cautious of this when it comes to solving for x. You have to think of it logically as well, where x must be less than or equal to negative 5, and x must be greater or equal to 5. That right there represents the domain for question 1, where domain consists of all real x values such that x is less than or equal to negative 5 and x is greater or equal to positive 5. To find out our range, we need to find out what happens when x is greater than 5, and we need to find out what happens when x is a lot less than negative 5. So let's go ahead and do that. Let's pick numbers for our equation where x is a lot more negative than negative 5. So let's say we had the square root of negative 100 squared minus 25. That gives us a fairly large number, and in fact, the more negative the number is, the bigger y becomes. Let's also check what happens directly at negative 5. If we replace this with negative 5, we end up with 0. This tells me so far that my range is between 0 and positive infinity. Let's try a really large number. This time, a positive number like 5,000. Notice that the y is quite large. And in fact, if I replace this with simply positive 5, I end up with 0. Therefore, I can conclude that my range consists of all y values where y must be greater or equal to 0. Let's move on to question 2. This time they want us to find the domain and range of y is equal to 4 over the square root of 1 minus x. The denominator we know can't be 0. You can't divide any number by 0. So the square root of 1 minus x cannot equal to 0. Let's solve for x. We square both sides. Solve for x now. Bring this over. X cannot equal to 1. Furthermore, within this square root, 1 minus x can't be less than 0. So 1 minus x needs to be greater or equal to 0 for this square root to be valid. Bring this x over. This tells us that x needs to be less than or equal to 1 in order for this to be valid. So to show this on a number line, let's pretend that this right here is 0. This suggests that x cannot equal to 1, so I'll put a dashed line along x is equal to 1. In addition, x can be anything other than 1 or more. So anything this way is valid. This tells me that my domain includes all x values that are less than 1. So domain for our function includes all real x values such that x cannot be greater than 1. Now let's find out what happens for our range when x is equal to 0, when x is very close to 1 from the left side. Let's choose 0.99999. And when x is a very large negative number, let's choose negative 100. Using this function, we have 4 over the square root of 1 minus 0. We get 4. Y value of 4. Let's see what happens when x is very close to 1 from the left side. We end up with a fairly large y value. Let's choose an even bigger value. And y continues to increase. So we can assume that y goes to infinity. And let's choose a very negative number, negative 100. We get a fairly small y value. And just to be extra cautious, y continues to get smaller and smaller, but never quite approaches 0. This tells me that my range consists of all real y values such that y is greater than 0. The solution for question 3 will be shown on part 4, so make sure you watch part 4 for more examples. And there you have it. That is how to find the domain and range of functions.